Dowsing and Archaeology. Part 2. By Guy Underwood. The test of the connection of dowsing with prehistoric structures can be made with little difficulty. The best site is a round barrow of the Bronze Age, of which large numbers exist in the country. A few barrows of the Roman and Saxon periods have been found, mostly in East Anglia, which will be unlikely to show the characteristics described, but the great majority of round barrows are of the early and middle Bronze Ages, 1900 to 1000 BC, and on all these there should be found a number of intersecting streams, usually called a blind spring, at the center of the barrow. If this is confirmed by other independent observers, then the proposition that dowsing formed an integral part of the prehistoric religions should be established in the minds of all reasonable people. Such a proposition, however, is of great and revolutionary importance in archaeology. It will be fought tooth and nail by many, and wide acceptance does not necessarily follow proof for a considerable time. The most ingenious arguments will be produced by the captious to throw doubt upon it. It is an unjust world. Interesting examples of blind springs and of the obsession of the ancients with underground water are given in Figure 1. The site is of the Bronze Age, and contains 3 barrows. It is enclosed on 3 sides by long mounds, usually called Celtic field walls, but in this case possibly of earlier date than the arrival of the Celts, which began about 750 BC. The boundary on the Essie consists of a sloping bank known as a lynchet. Numerous oak trees grow on the site. The subsoil is limestone, and the upper soil, below the humus, is brash. The whole enclosure covers about 2 acres, of which about half is illustrated. The other half does not contain so many streams. The central barrow, A, has 16 streams radiating from its blind spring, B has 14 and C 11. It is of outstanding interest that this enclosure, like those around Jugg's grave previously referred to, appears to have been undisturbed by agriculture since it was abandoned. It seems unlikely that this abandonment occurred later than about AD 60, when the last representatives of the prehistoric religions in this country were suppressed by the Romans. The ground surrounding the barrows contains about 250 stones, all recumbent, except one which is standing. These stones appear to mark the courses, and particularly the intersections, of underground streams, most of which come from the barrows. Only about 25 stones are not in positions related to stream courses, and it is possible that some of these may have been disturbed by the felling and removal of trees which has, no doubt, taken place periodically. The existence of these stones suggests that similar watermarking stones may have existed on other sacred sites elsewhere but have been removed. One of the first things done by a cultivator is to remove large stones. Practically all such sites known have been under cultivation at some time or another. A line of large stones NW of Barrow A has much the appearance of outcrop. I doubt this, but as yet none of the stones around the barrows have been disturbed. Barrow A contained a circle of standing stones, called a peristolith, arranged round the central burial chamber or cist. 7 out of 8 of these stones marked places where fissures radiated from the center, and there were 4 stones on the outside edge of the barrow marking places where 4 other fissures very close together emerged. The courses of 11 out of the 16 streams were therefore marked, and it is difficult to suppose that this was accidental. Other standing stones may have existed formerly but may have been disturbed by roots or other causes. The dowsing reactions found on prehistoric sacred sites are seldom strong. One reason may be the dissipation of the available water into a web of small fissures. Few of them would provide substantial water supplies, a fact that has probably saved many ancient monuments from destruction. Mr. George Applegate has, however, recently brought to my notice a water pumping station at Shepherd's Shore, near the Wands Dyke, on the Devizes Marlborough Road. This is connected by a stream to a cluster of barrows nearby, and one of its pumps appears to be sited on a blind spring of 14 radii. It seems likely, therefore, that a barrow at one time existed on the spot. Underground streams vary from immense supplies, such as that obtained from a well sunk recently at Chippenham which produces 3 million gallons a day, down to water-bearing fissures which are little more than damp cracks. Both can be located by dowsing, but, in my personal experience, a rod which responds easily to the great supplies may not respond at all to the smaller. I am aware that certain exceptionally skilled and sensitive positive dowsers are able to sense the smallest reactions with a twig. I cannot do so, and in my opinion the ordinary dowser who attempts it is very like a short-sighted person trying to read without glasses. All he will get with any certainty are the headlines. As an example, Captain Boothby and Reginald Smith, both of whom used either the twig or pendulum, found only a few streams at Woodhenge, and at Stonehenge. My observations with sensitive rods showed 16 streams at Woodhenge and a multiplicity at Stonehenge. For this reason, it is important to use a sensitive rod, in order to get all the streams and their correct courses, so that no other competent dowser can obtain a different result. The rod I have found most suitable for this purpose is illustrated in Figure 2. Number 1 is made out of 3 twigs tied together with string. Number 2 is made from plastic knitting needles, size 10 or 12. Number 3 is made from spring steel. Number 1 is a useful makeshift, but will not rotate. It can be used for tracing the streams but not for gauging strength. Number 2 will rotate, but is somewhat fragile. Number 3 is the most satisfactory. The instrument consists of a flexible rod, R, a handle, H, and link, L. The loops of thread enable it to be folded for the pocket. The stops, S, are to keep the loops in place, and can be made from rubber. It should be held as shown, with a slight pressure on the rod R. It has the advantage that the dowser can see whether it is in equilibrium, or not, and as it has little static friction, it responds practically instantaneously. It can be used for all dowsing purposes, and is easy to use. Sensitiveness can be altered by varying the gap between the rod and handle. The gap I find best is about 1 inch. Many people think that they cannot dowse, merely because they cannot use the twig. In my experience, any person whose nervous system is normal, and whose reflex actions are therefore normal, can dowse, provided that they will take the trouble to learn. I am hoping that this new pattern of rod will, by enabling more people to dowse, throw further light on the dowsing influence, the precise nature of which is unknown. The tracing of streams with a sensitive rod can be done at a good pace. The stream, when found, is followed by criss-crossing it diagonally, and the rod will give a good and clear nod each time the stream is crossed. The dowser should try to proceed in a straight line. He will soon notice if the stream bends, by the failure of the rod to indicate. The direction of the bend is easily found, and the dowser then continues as before, but on the new line. A marker should be put down periodically on streams that do not run straight, and on complicated sites it is an advantage to mark the course of each stream with thin string, so that it will not be confused with other streams, can be verified, and its course recorded later. Fissures often cross each other at narrow angles, but if marked by strings their courses can be checked with ease. See later as to surveying. There is often misunderstanding as to underground streams in the minds of the uninitiated. Some of them seem to visualize babbling brooks running a few feet below the surface. They find this proposition difficult to accept, and are liable to doubt all other statements made by the dowser. As streams in stone formations usually run in fissures, it may avoid misunderstanding, if they are referred to as fissures until some more esoteric word can be found. This appears to be one of the few known instances of insufficient jargon in any art, cult or profession. Archaeology can do better than that. For example, certain very ancient flint implements have been found which are shaped, like the hull of a ship, with one end slightly turned up. Their use is unknown. We do not call these hull flints, that would be too comprehensible to the uninitiated. Ship shape would never do. We call them raw-stroke carinate, Latin rostrum, a ship's prow, and carina, the bottom of a ship. This priceless pearl of jargonese has its uses however, as, if anyone tries to argue with us, we have only to mention the word, and if he does not understand it we know at once that he is a mere tyro whose opinions can be ignored or contradicted with impunity. It was Sir A. Lancaster who contributed this spellbinding word to our suffering language. The facts are that underground water, usually at considerable depth and pressure, forces itself through beds of gravel or sand, or narrow fissures in the rock, trying to find an outlet where its pressure can be relieved. Some idea of the depth and pressure of some streams can be obtained from the hot springs at Bath. Here the temperature shows that the water must come from at least 3,600 feet below the surface, and that the pressure, at its full depth, must be well over half a ton to the inch too. Such a pressure is considerably in excess of that in any normal high-pressure steam boiler. It is only in places where the rock is of a kind particularly soluble in the acids carried by the water from the surface, as, for example, in the Mendips, that free-flowing streams are found running through caves. Such streams can be seen at Cheddar and Wookey Hole. It seems a pity that so much emphasis has been placed on water in connection with dowsing. The fact that it is possible to find water supplies by dowsing is an isolated and, possibly, minor phenomenon of a far more important physical fact, the existence of a geophysical force so far not identified. The inclusion of the word water in the name water divining seems to dilute the importance of the subject as much as that liquid detracts from the effectiveness of other, and by some considered more precious, fluids. Most of my readers will be aware that there are two kinds of dowsing influence, positive and negative. The narrow line of influence above the stream is positive, and the broad bands of influence on each side are negative. It is not so generally known that there are two kinds of dowser. The normal dowser is more sensitive to the positive, while the so-called ultra-sensitive, village or natural dowser feels the negative more strongly. In country districts the village dowsers are almost all of the latter type. They number only about 1 in several thousand of the local populations, although some others have the peculiarity without realizing it. It is probable that it is the rareness of this particular kind of dowsing sensitiveness, which has led to the erroneous idea that only a few specially gifted people can dowse, a statement which the village dowser makes frequently. The special sensitivity of this kind of dowser appears to be due to a peculiarity of their nerve centers. I have made some experiments which seem to confirm this, and see also Dr. J.A.S. Elmsley, in the Journal of the British Society of Dowsers, Volume 1, Number 3, page 47 and Volume 2, Number 10, page 106. When a number of streams are close together, as on a sacred site, the wide negative influence bands overlap, become confused and cannot be followed. The narrow positive bands, however, remain clear, and can be distinguished at a distance of a foot from each other. A negative dowser, therefore, cannot locate the streams of such sites. I have tested this several times with competent village dowsers. I have also tested similar sites with dowsers of the positive type. They had no difficulty in finding and following the streams illustrated in Figure 1. In two cases, independently of each other, they pointed out that I had omitted stream number 51A from my plan, although unknown previously to them. It follows, therefore, that the ancient priests must have been positive dowsers, that is to say, normal people who had learned or been taught to dowse in a special way, rather than natural dowsers of the negative type. It is known that water had a religious significance to the prehistoric peoples and, as Reginald Smith pointed out, every religion has a use for it. He also suggested, however, that menhirs and other isolated standing stones were watermarks for use in case of public emergency. Although prehistoric sacred sites were associated with underground water, I doubt whether the water was of any utilitarian importance to the ancient dowsers. They must, however, have realized the connection of water with dowsing, as underground streams can often be traced to where they break out as springs. I have only found evidence in one place of any distinction appearing to be made between strong and weak streams. This is at Freshford, wilts, where the largest stones mark the strongest streams. It seems unlikely that the ancient peoples had any need for artificial water supplies. Wells become a necessity only with large populations. In the later Iron Age there was a great population in this country, and Caesar, who paid us visits in 55 and 54 BC, tells us that the population was innumerable. We have no reason, however, to suppose that this country was as thickly populated nearly 2,000 years earlier, although we do not know for certain. We do know, however, that the people of those early times could not sink wells in the limestone or harder rocks, as they did not possess the metal tools essential for the purpose. It follows, therefore, that the association of water with sacred sites and with menas and similar standing stones, had no relation to water supply, although probably considerable relation to water sanctity. Surveys. Sometimes the dowser may wish to make a record of what he has found, in other words, to survey it. The equipment he will need is as follows. A surveyor's 100 feet tape measure. A number of markers. I use bamboo canes 2 feet long for markers, and aft. And 4 feet long for special marks. Thin string and something to wind it on. A compass. Sectional paper and a notebook. A canvas bag to carry the markers, similar to a small golf bag, which can be slung over the shoulder, is useful. Small stone circles, such as Woodhenge, near Amesbury, and the Sanctuary, near Avebury, are easy, as the positions of all former stones are marked by concrete posts. Round barrows are also easy. After finding the blind spring, a marker should be inserted in the center and 2 more north and south of it and at equal distances. These 3 will make your baseline. 2 more are set at the same distance from the center at right angles to the baseline, so as to make a square, and string is laid round the 4 outer markers to show the line. Do not cut the string, as knots are a nuisance. Draw the square to scale on sectional paper, and also the rough outline of the barrow, marking the north or any permanent feature onto which the baseline has been aligned. The radiating streams should first be marked by laying down markers near the center, and then all positive reactions on the outside of the square should be marked by inserting markers. Starting from the nearest marker to where you have tied the string, trace that positive reaction. If it leads to the center, wind the string round the center marker and trace the nearest stream from the center to the outside, and so on. Mark any transverse streams. When completed, lay your tape measure along one side and mark the streams on your plan, and so on until all sides are completed. This is the best test of dowsing and of dowsing skill that I know of, as 2 good dowsers should produce identical plans independently of each other. A long barrow is more difficult. A baseline should be made along its long axis, with large markers every 50 feet. Similar lines should be made on each side, at equal distances from it and with similar markers. This will produce a rectangular enclosure called a grid. Then, proceed as with a round barrow. You may need 200 markers and several pounds of string and several days to do it. You cannot use string if there are cattle in the field, as they will eat it. It is disconcerting to both parties to have to pull many yards of string or tape measure from their cuds, and it spoils the tape measure. Every small object that you are likely to use and lose, rod, pencil, India rubber, etc., should be tied onto yourself with string. I have lost many such things in the grass. It is a good idea to tie something bright red. Plastic tape, procurable at Woolworths, is good, to every object, in case you drop it. The most difficult sites are those with large open spaces and few permanent marks. The subject is vast, and there are many questions which one individual alone cannot investigate. For example, had the direction of flow of the water in the streams any significance? Long barrows are usually aligned upon 2 parallel fissures, and are usually oriented with their larger end towards the east. I have never been able to distinguish the direction of flow of a stream, but some dowsers claim to be able to do so. If they can do so, it seems probable that the ancients could do it also. It would be interesting to know whether the direction of flow of the water is always the same in relation to the larger end. As to long barrows aligned on streams, but not oriented, it would also be interesting to know the direction of flow and the ultimate courses of the streams. A good example of the latter type of barrow is Belishnapp, near Cheltenham, which I have not yet been able to survey. It is the only known example in the Cotswolds of a long barrow which is not oriented. It is one of the most perfect long barrows in Gloucestershire. Another question is whether conditions on sacred sites in foreign countries are the same as those here. For example, the stone circles of India, the prehistoric burial mounds found in most countries and particularly the pyramids, mastabas and temples of Egypt. I feel some doubt about Louis Merle's statements that burial mounds in France are located on sites surrounded by intersecting streams. Such places are common and could hardly therefore have had any special sanctity. One of the first principles which a young lawyer learns is that it does not matter so much whether or not he has a good case, what really matters is how good a case can be put up against it. His chief concern, therefore, is to find out what the other side can say, and to be provided with the answer. It is wise, therefore, to see what objections can be raised to our own case. In order to test this, I sent copies of the first part of this article to a number of experts. One replied that he would hesitate to test the proposition as, if he found it to be true, he would think he was mad. The main objections were as follows: even if established that sacred sites do show the characteristics described, it may be that exactly the same characteristics exist elsewhere where there are no prehistoric remains. Can you prove they do not? The only real answer to this is, here is a rod, show me instances. I have never found them elsewhere except where there were other reasons for thinking it probable that such sites had existed. Such places however must exist, as immense numbers of barrows have been destroyed by agriculture, that most potent of all levelers. This line of objection is the old gambit of the skilled debater trying to persuade his unwary opponent to attempt to prove a negative, while his tormentor sits at ease and watches him. It has often been used against dowsers. A well is sunk, and ample water found where the dowser indicated. Naturally, he turns to the skeptic and asks if he is now convinced. The reply is certainly not, there may be water everywhere here, but if you will point out a place where there is no water, and dig another well, then if no water is found I may perhaps believe in it. You cannot persuade the prejudiced so long as he can save himself from looking foolish. Another question is likely to arise: what possible reason could the prehistoric priests have had for using dowsing in their religion? Here we can only speculate. Archaeologists never tire of telling each other not to make suppositions. It is a useful phrase with which to crush the enthusiastic but too uppish beginner. The latter soon finds out, however, that the difference between suppositions and reasonable deductions is that the former are his opinions, while the latter are those of his mentor. Much of archaeology is necessarily guesswork, and I prefer the honest guess of someone who has studied his subject to the pretentious evasions of the pseudo-learned. Many textbooks on archaeology are full of suppositions, and descriptions of life in the Bronze Age by some of the high priests of the cult display powers of imagination which should have brought to the talented authors rewards far in excess of those that can be extracted from the dull study of prehistory. Supposition is really another name for theory. Theories stimulate inquiries and can be very useful. They are also very enjoyable. Mine are therefore, first, that it was good magic, and, secondly, that its primary practical use was for fixing boundaries. Magic is the exhibition to the uninitiated of the effects of controlled physical forces. We have much evidence that magic formed a large part in the prehistoric religions, and also that the priests made a study of natural philosophy, or what we now call physics. I have heard it propounded that the methods of Joshua in dealing with persons with whose opinions he did not agree suggest that he had a knowledge of explosives. The peculiar mystery of dowsing must have provided an added attraction. Even now we do not know the cause. As to boundaries, here dowsing would be particularly useful. Boundaries so fixed are unalterable. If the marking stone was moved, the priest could identify the spot from which it came. He would gain much kudos by doing so, as both the criminal and the injured party would know the true facts. Boundaries were of particular importance to the ancients. The functions of the deities Thoth, Hermes and Mercury included the fixing and maintenance of boundaries. There are also indications suggesting its use in the laying out of processional ways or avenues. Although Reginald Smith refers to certain complexes of underground streams as blind springs, I am inclined to think that some of them must be merely multiple intersecting fissures. The name, blind spring, however, is convenient. They were not the only geological features sacred to the ancient peoples. Other and rarer geological peculiarities exist and appear to have been of greater sanctity. Blind springs were associated mainly with barrow burials, but are often found also in the center of stone circles. There does not appear to be a blind spring in the center of the large circle at Stanton Drew, near Bristol, although there is one in each of the smaller circles there. I doubt whether a blind spring was regarded as sufficient by itself to justify the erection of a circle. I am inclined to think that, associated with all stone circles, there will be found certain features which I propose to describe in my next article. Burial in barrows is generally taken to have commenced in this country at about 2500 BC and to have largely ceased with the end of the Middle Bronze Age at about 1000 BC. All the barrows of that period appear to have been on blind springs. Blind springs are in the nature of geological freaks, or remarkable coincidences, as it is obvious that towards the end of the 1500 years of barrow burial they must have become increasingly hard to find, and, in the end, practically exhausted. It would be interesting to know whether this was any part of the cause for the change of burial customs in the late Bronze Age. During that period, burials were mostly in urns set close together in cemeteries called urn fields. I have so far only tested one case. There, although associated with streams, there was no indication of a blind spring. One of the streams, however, appeared to link the urn field to a nearby barrow. The proof of a theory is in its application, and I have recently been applying this one to our principal prehistoric monuments, Avebury, Stonehenge, Stanton Drew, etc. About all these there are many things which are not understood and upon which archaeologists have argued for generations. For example, much ink has been expended on trying to find an explanation for the two station stones at Stonehenge. Another question is, why is the heel stone exactly where it is, and not nearer or farther away from the monument, as it could be without destroying its supposed function as a dial stone? In my last article, it was shown that Dowsing supplies reasons for these. As to Avebury, what is the reason why the main avenue takes the course it does, and what was its course where not known? How many avenues were there, and what were their courses? What is the meaning of the apparently inexplicable line of stones found recently in the South Circle? Why is the Great Circle not circular? There are many other such questions, but above all is the paramount and overwhelming question, why are these great monuments located where they are? If the answer to the latter question can be provided, it would affect archaeology vitally wherever the remote past is studied. Dowsing appears to throw light upon most of these questions. Few experiences are more fascinating than to travel in an undiscovered country, or in one that is new to us. Most people have been enthralled by those stories of H.G. Wells, Dean Swift and Samuel Butler which depend for their attraction upon the comparison of experiences in our own country with those in other places where values are different and where things are done for what seem to us to be no good reason. For the last 6 months I have been doing the same, but have gone backward 4,000 years into a community where every important religious action, and therefore presumably many others, appears to have been governed, or at least affected, by geological conditions. To be continued.